Let us start ICSE Mathematics Class 10th, Chapter 8, Matrices. Definition: a matrix is an ordered rectangular array of a number or functions. The number or functions are called the elements or the entries of the matrix. We denote the matrices by capital letters. Example great here. A is a matrix, capital A, and its elements are -2, 5, 0, √5, 3, 6. And these numbers are bracketed by square bracket. There is second matrix B, so its elements are, or entries are 2, 3, -1/2, 3.5, -1, 2, √3, 5, 5/7. Again, these elements have been put inside the square bracket. Capital C, you see 1 plus x, x square, 3, cos x, sin x plus 2, tangent x. So again, this matrix is also put, elements are put inside the square bracket. The horizontal lines, these are the horizontal lines are known as rows, and the vertical lines, see, vertical lines are known as columns. Now, order of matrices. You see, what is the order of a matrix? A matrix having m rows and n columns is called a matrix of order m into n, or simply m into n matrix, which is read as an m by n matrix. In general, an m into n matrix has the following rectangular array. You see, the first element has been written as A11. The first one numbers that indicate the number of rows, means which row is. So it is the first row. So again it is the first column, that is why A11. Now we come to this second one. It lies in the first row, that is why it is 1. But it is in the second column, that is why it is written 1, 2. Now come to this place. Here it is the one first row and column is 3. So 1, 3. A1, 3. Similarly, if you reach here, you will get ij, or you can say 1j, means the jth column is there. First row is there, that is why it will remain 1. 1j. So A1j indicate that this is the element of the first row and jth column. Similarly, if we proceed further, at the last it is written that A1n. So the last one, it is written 1n, means the first row, nth column. Now come to the second row, that is A21, A22, A23, A2j, and at the last you will get A2n. So similarly, if you proceed in this way, you will reach the ith row. Ith row, that is indicated here, AI1, AI2, AI3, Aij, Ain. So ith row. Here I have written ith row. Now come to the AM1 means the mth row and first element. AM2 the mth row second column. AM3 mth row third column. AMJ means mth row jth column. AMN means mth row nth column. So this will be order of m into n. You see how many rows are there? M rows. How many columns are there? N rows. So I have written here m into n. This m into n indicate the order of the matrix. Now this can be written in this way also. A means the capital A indicate the matrix. Aij. Aij means I letter indicate the ith row. J indicate the jth column. So that this is the ith row and jth column element is written here, and in outside I have written m into n means that is the order of this matrix. Now come to this. What is ith? Ith is it is equal to 1 or greater. 1 is less than or equal to ith means ith will be either it will be 1 or greater than 1, or it can be also said that 1 is less than or equal to I. Means the value of I vary from 1 to m. You see, 1 is less than or equal to I and I is less than or equal to m. Means its value start from 1 to m. That will indicate the row. Now come to the j column. You see, the value of j, that is 1 is less than or equal to j and j is less than or equal to n. Means the column start from 1 to n. So it can be written here 1 is less than or equal to j and j is less than or equal to n, where I and j belongs to natural number. Now Aij is an element lying in the ith row and jth column, or Aij is called the ijth element of the matrix A. Number of elements in an matrix m into n order matrix, m into n order matrix will be m into n. You see, the number of elements in an m into n order, that is the order of the matrix, will be mn. Now come to the types of matrices. You see, matrices is the plural word for matrix. So types of matrices, first one is column matrix. A matrix which has only one column. Such type of matrix is called column matrix. You see, here this matrix is having one column and 4 rows. You see, rows are 1, 2, 3, 4. 4 rows and 1 column. So is a column matrix of the order 4 into 1. In general, it can be said A means the matrix A, inside the bracket A, ith and jth, bracket closed, m into 1 means m into 1 means mth row and 1 column is the column matrix of order m into n. Now come to the row matrix. A matrix is said to be row matrix if it has only one row. Example criteria. There is a matrix B in which only one row is there, but there are 4 columns. So in the first row, minus 1 by 2, root 5, 2, 3. In general, it can be said B is the matrix in bracket. Small b means the element ij, bracket closed, 1 into n is the row matrix of 1 into n. So it is only one row. Now come to the square matrix. And m into n matrix is said to be a square matrix if m is equal to n. Means the number of rows and number of columns are equal. That matrix is called as a square matrix. You see, for example, A. There are 3 rows, 1, 2, 3, and 3 columns. Is a square matrix of the order 3. In general, it is said A inside the bracket, small a, that is element, indicate element, ijth element is indicated here, m into m means m order is a square matrix of the order m. Now the fourth, diagonal matrix. A square matrix is said to be a diagonal matrix if all its non-diagonal elements are 0. That is, capital B means the matrix B and its elements are Bij inside the bracket, m into m is said to be a diagonal matrix if Bijth is equal to 0 when I is not equal to j. When number of rows is not equal to number of columns, that element that indicate the elements should be equal to 0 where I is not equal to j. You see here, matrix A, there is 4 inside the bracket, that is 1 into 1 order. B, minus 1, 0, 0, 2, means you see here the 1, 1 and 2, 2, and the rest other terms are 0. Similarly, in the C matrix, you see, minus 1.1, 0, 0, 0, 2, 0, 0, 0, 3. You see, this 1 minus 1.1 is the element in 1, 1. 2 for its row is 2, column is 2. Here 3 is the element of third row and third column. So 3, 3 are the diagonal matrix of the order 1, 2, 3 respectively. Now come to the scalar matrix. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. That is the square matrix B inside the bracket Bij, small letter that indicate the elements, n into n. N into n is said to be a scalar matrix if Bij is equal to 0 when I is not equal to j. At that time, it should be equal to 0. That element should be equal to 0 where the number of rows and number of columns are not equal. Such elements should be equal to 0. Now we come to Bij equal to k when I is equal to j, means the number of rows and columns both are same. At that time it should be a k where k is some constant term. Constant, you see, for some constant k. Example criteria A, that is 1 into 1, that is 3. B minus 1 you see here. C, that is root 3, root 3, root 3. Such type of matrix is known as scalar matrix, whose diagonal elements are some constant number. The same constant number is there. Or scalar matrix of the order 1, 2, 3 respectively. Now, identity matrix, a square matrix in which the elements in the diagonal are all 1 and rest are all 0 is called an identity matrix. In other words, the square matrix A, that is in small letter A in bracket, Aij, n into n is an identity matrix if Aij equal to 1 and 0 if I is equal to j, at that time it should be 1. Or identity matrix means if 1 1, 2 2, 3 3, 4 4, that should be 1. So I is equal to j. And if that element is 0 if I is not equal to j. We denote the identity matrix by I. You see, the matrix of the order n by in, you see, identity matrix of the order n by in. It is indicated like this, in. When the order is clear from the context, we simply write it as I. Example criteria, you see 1 1, you see 1. Again here you see 1 1 and 2 2 are 1 1 number. So this is also identity matrix of the order 2. Here you see 1 1, 2 2 and 3 3. These are only 1 1. So our identity matrices of order 1, 2, 3 respectively. Here its order is 1, here its order is 2, here its order is 3. Scalar matrix is an identity matrix. Scalar matrix is an identity matrix when k is equal to 1. But every identity matrix is clearly a scalar matrix. Every identity matrix is a scalar matrix, but all scalar matrix is not identity matrix. Only those scalar matrix will be called identity matrix provided k is equal to 1. Now come to the zero matrix. A matrix is said to be zero matrix or null matrix if all its elements are 0. Example criteria, you see the 0. Here the second order is 0 0 0 0. All the elements are 0. We denote the zero matrix by 0. Its order will be clear from the context. Context means what are the elements, how the elements are, and what is the number of the elements. So accordingly we can visualize the order of the matrix. Now proceed to the exercise 8a. Question number 1. Write down the order of each matrix given below and the number of elements in each. You see, it is written here 1, -1, 7, 4. Now you see the 2 rows and 2 columns are there. So the order is 2 into 2. The number of elements will be 2 into 2, that is 4. So this will be the answer. Second part, sin theta, cos theta. So it is only one row, but columns is 2. So order is 1 into 2. The number of element will be 1 into 2, that is 2. Now here in C, there is only one row, that is, and how many columns are? 1, 2, 3, 4. So the order is 1 into 4. Number of elements is equal to 1 into 4, that is 4. Now come to the fourth, that is 1, 2, 3. So order is 3 into 1. Now the number of elements is 3 into 1, that is 3. Its answer is 3. Now fifth, you see the 2, 0, 0, 0, 0, 2, 0, 0, 0, 0, 2, 0. Its order is, you see the number of rows is 1, 2, 3. Column is 1, 2, 3, 4. So the order is 3 into 4. Number of elements will be equal to 3 into 4, that is 12. Come to the sixth part, there is 1, 2, 0. Here 1, 2, 0, minus 5, 7, minus 7, minus 2, 0, 3, 1, 8, 5, 4, 4, 2, 9. Now the order will be 3 into 5 because 3 rows are there, 5 columns are there. Number of elements will be 3 into 5, that is 15. Its answer will be 15. Now come to the seventh part of the question, that is 1 minus 2, 3 minus 5, 5 minus 9, 7, 0. The order is, you see the number of rows is 1, 2, 3, 4. So the order is 4 into 2. The number of elements will be 4 into 2, that is 8. Now come question number 2. To classify the following matrices as equal or not equal. You see in this elements are 1, 0, 0, 1. Now we have to see the corresponding elements. Here you see the 1, 1 means first row, first column. That is, here it is 1, here it is 0. So they are not equal. The corresponding elements are not equal. Hence, this will not equal. You see, the order is the same, 2 into 2. But the corresponding elements are not equal, hence not equal. This will be the answer. Now come to the second part. Here you see 4. Here you see 3 plus 1, that is 4. Here you get 7. Here you get root 49. Means, solve it, you will get 7. So the 7 and it is also 7. Solve it, you will get 7. Here it is 3. Here it is 5 minus 2, that is 3. So the corresponding elements are same. Now here it is 2. Here 6 by 3, that is 2. If you solve it, you will get 2. So the order is same and the corresponding elements are equal. Therefore, it is a equal matrix. Now come to the question number 3. You see, construct 2 into 2 matrix A where small a, ij are given by aij equal to 2 into I minus j whole square. Means if you want to find out the first row, first column elements, then you have to put in place of I 1, for j just put 1. You see 1 1. A 1 1 means the first row, first column element. That is in place of, you see, 2 into 1 minus j, that is 1 whole square. Solve it, you will get 2 minus 1 whole square, that is 1 square, again 1. So your first row, first column element will be 1. Now come to A1 2. That is 2 into 1. Here I is 2. J is 2 into, the formula is 2 into I. So 2 into 1. 1 into 2. 1 into 1, 2 means first row, second column. First row, second column. So according to this formula which is given here, we have to substitute it. So 2 into 1, 2 into 1 minus 2. Why minus 2? Because the j is the number of column. So this is the first row, second column. So 2 into 1 minus 2 whole square. Solve it, you will get 2 minus 2, that is 2 square, that is 0 square, that will be 0. Now come to the second row, first column element, that is A21. That is, you just put the value of I, means the 2. So 2 into 2. For j you have to put 1. So again 1. So 2 into 2, 4 minus 1, that is 3. 4 minus 1, 3. Whole square, that is 3 square, that is 9. Now come to this row. A22 means second row, second column. So 2 into 2 minus 2. So 2 into 2, 4 minus 2, that is 2. 4 minus 2, that is 2. 2 square, that will be equal to 4. Therefore, the matrix A will be 1, 0, 9, 4. You see? 1, 0, 9, 4. I have substituted all these values here. So our answer is this. Now come to the question number 4. For matrix B, you see, matrix B is given, that is 3, 11, minus 5, 6, 8, 0. So the question is asked here, what is the order of the matrix B? Means 3 rows are there, 2 columns are there. So the answer will be 3 into 2. State the elements. A1, 2 means the first row, second column. What is that number? First row, second column. That is 11. So A12 is 11. Now come to A31 means, 31 means the third row, first column. So it is 8. That is why I have written here 8. Now come to the A22 means second row, second column, that is 6. Here you see 6. Now B is a square matrix. True or false? You see, is it a true or false? Number of rows and number of columns are same? No. Because there are 3 rows and 2 columns. Therefore, it is not a square matrix. We have to choose the correct answer from true or false. That is false. Answer is false. Now question number 5. A matrix has 6 elements. Write the possible order of the matrix. There are 6 elements are there. We have to write down the order of the possible order of the matrix. So it may be 1 into 6 or 6 into 1 or 2 into 3 or 3 into 2. These are the possible order of the matrix where the 6 number of elements are present. Now come to the second part of the question. That is, if a matrix has 3 rows and 4 columns. 3 rows are there and 4 columns are there. What is the number of elements in the matrix? Answer is, number of elements will be equal to 3 into 4, that is 12. This will be the answer of the question number 5, second part. Now come to the question number 6. First part, you see, find x and y such that, first one is x, y, minus 1, 5 is equal to minus 2, 0, minus 2, 5. You see, if it is equal, it means that the corresponding elements should be equal. If two matrices are equal, then their corresponding elements should be equal. So x correspond to minus 2. So x is equal to minus 2. Now you see y. Y correspond to 0. So y is equal to 0. Now come to the second part of it. x4. Here it is minus 2y. So x correspond to minus 2 because there is a equal sign. So the corresponding element must be equal. Only then these two matrices will be equal. At that time, x will be equal to minus 2. And what will be the 4 correspond to y? So y is equal to 4. I have written here y is equal to 4, x is equal to minus 2. Now come to the third part of it. You see the matrix is given, that is 2x 3 0 y minus 1 is equal to x minus 4 3 0 5. So 2x equal to x minus 4. Transpose this x to one side, so you will get x is equal to minus 4. This will be the answer. For y, what you do, that is corresponding elements, you see, y minus 1 equal to 5. Y minus 1 equal to 5. So y minus 1 is equal to 5. Therefore, y is equal to 1 plus 5, that is equal to 6. This will be the answer. Now question number 7. Find P, Q, R and S if P plus 4, 2Q minus 7, S minus 3, R plus 2S is equal to 6 minus 3 to 14. So we have to see the corresponding elements. You see P plus 4 correspond to 6, 2Q minus 7 correspond to minus 3. Here S minus 3 correspond to 2. R plus 2S, that correspond to 14. So here I have written P plus 4 equal to 6. Again solve it. P will be equal to 6 minus 4, that is 2. This will be the answer. 2Q minus 7. 2Q minus 7 correspond to minus 3. So 2Q minus 7 correspond to minus 3. Therefore, the Q is equal to 7 minus 3 by 2. Solve it, you will get 2. S minus 3 equal to 2. S is equal to 3 plus 2, that is equal to 5. Answer is, this will be the answer. Now, R plus 2S is equal to 14. So we have got the value of S here. Substitute the value in this equation. So R plus 2 into 5 equal to 14. Now 2 into 5, that is 10, that transpose this 10 to this right hand side. You will get R is equal to 14 minus 10, that is equal to 4. Now come to the question number 8. Answer the true or false. Every zero matrix is a square matrix. False. A unit matrix is a diagonal matrix. True. A zero matrix is a matrix of the order 3 is a diagonal matrix. False. You see the fourth one, that is 1 1 1 1 is a unit matrix. False, because only the diagonal element should be 1. But here all the elements are, only diagonal element should be 1. That is why it is false. A matrix is an aggregate of number. It is a false. It is an array of the numbers. Array means that arrangement, you can say. 6th, that is 3x 0 2 equal to 3 4 1 2 if x is equal to 4. You see, if x is equal to 4, we have to see the other corresponding part, not only x. You see, 3 correspond to 3, x correspond to 4, 0 correspond to 1, 2 correspond to 2. You see, the 0 vary. It does not tally with this. So 0 is not corresponding to 1. That is why it is a false. If x is equal to 4, again it is a false. Because once there is a sign of equality, the corresponding element should be equal to the corresponding element of the other matrix. Now come to the seventh part, that is 1 0 0 1 is the identity of the matrix for addition of 2 into 2 matrix. Again it is a false. Now come to the question number 9, which states that the length and the width of the and height of two boxes are 6, 5, 10. 6, 5, 10 and 5 to 5, 5 to 8. The second box is 5 to 8. Write this set of numbers in the matrix form so that first column indicate the length, second indicate the width, and third indicate the height. You see, I have written length, width, height. The box 1, its length is 6, width is 5, height is 10. Box 2, length is 5, width is 2, height is 8. Now there is another. So a third box is corresponding dimensions are 7, 3, 3. Write a 3 by 3 matrix describing the dimension of the 3 boxes. You see, I have written the 3 boxes here, box 1, box 2, box 3. The data given here above, that is the length is 6, 5, 10. So the length is 6, width is 5, height is 10. Similarly, for the second box there, length is 5, width is 2, height is 8. Box 3, the length is 7, width is 3, height is 3. Now come to the question number 10. Question number 10, you see it states that 3 people in an algebra class score marks in 3 tests as follows. Akhil 79, 87, 92. Rajneesh 95, 98, 91. Sudha 76, 88, 77. Display the information as 3 by 3 matrix. You see, I have displayed it here. You see, Akhil, test 1, test 2, test 3. So the marks have been substituted here, 79, 87, 92. Rajni's marks, that is in test 1, that is 95, 98, 91. Sudha, first test is that is 76, second is 88, third test 77. So it is a 3 into 3 because 3 rows are there, 3 columns are there. So 3 into 3, order is 3 into 3. This will be the answer. Now come to the second part of it. That is, if the price of the record is rupees 30 and the blade of packet is rupees 1.50 and the soap cake is rupees 1.70, display the price as 3 into 1 matrix. You see, we have to display the information into 3 into 1. You see, there is 3 rows, 1, 2, 3 and 1 column. So 3 into 1 order is there. Record is 30 rupees. Blade packet 1.50. Soap cake is 1.70. So this will be the answer of this question number 10.